Hello, today we are here with Andy Bailey and we are going to talk about legacy modernization, a lot of things going on in the field. So, this conversation I think is going to be super interesting. So, welcome, Andy. And I will start right away with the first question so we can extract as much knowledge we can from you.
Okay.
And And can you tell us about your background and how you got involved in legacy modernization in the first place?
I think, well, I've been a software developer since I was 16, so this is an embarrassingly long time ago. Let me think. Yeah, 40 years ago, actually, over 40 years ago. Um, and I started off on the very basic machines that you had back then, the RML 380Z, and then when I was 18, I bought myself a BBC Micro, which is like brilliant, fantastic machine. Had a basic with an assembly compiler built in. Amazing machinery. And then I joined the British Ministry of Defence
Mhm.
as an apprentice, and I got my apprenticeship there, and then went on to doing IT consultancy. Started my degree in 1993 in computer science and artificial intelligence. And towards the end of my studies, this curious SDK came out called Java, and it made the claims of write once, run anywhere. So I thought, well, this could be interesting, and did the usual things with running GIF animations in the browser. Finding a browser to actually support applets at the time was hard, but we managed to get it done. And kind of left that behind for a couple of years until I was asked to write some software for an event calendar on the
Mhm.
internet. And also in parallel, I was doing a what was that called? Holiday Reise, yeah. Holiday company were building. You could build your own holiday on the
Okay.
website, and then they would do the rest, like booking the hotels and so on. But I built the front and back end for those, and there were very stark contrasting systems. One was built in Java, and back in the day, we didn't even have JavaScript for the front end, so everything had to be um, presented. CSS was like kind of a thing, so the styling of the websites was very primitive. So you had lots of grey background and not able to really fit the form elements the way you can even 20 years ago. But that was the event calendar was built in Java, and the holiday system, the customized holiday system, was built in Visual Basic. And I quickly decided which one I preferred. It was definitely wasn't the Visual Basic back then. With a Microsoft Access backend, which wasn't even capable of running multi-threaded code, connection pool of one. And yeah, so progressed from there. That was 1998, and since then I've concentrated my career on um, back-end Java processing, well,
Mhm.
development with some front-end, depending on the framework being used. Um, I have got quite a wide experience of how different front ends build in. So Spring MVC, um, uh, JSF. There was quite a few frameworks which allowed you to build very good front ends onto those. And then 9 years ago, I started working for a company that was uh, had their own software products for the insurance
Mhm.
industry, and we were integrating our software products and providing consultancy services for the modernization of existing or the integrating into existing systems. So were confronted with having to integrate with COBOL systems, in one case RPG. And then I decided I wanted a new challenge last year. Went to another company whose primary focus was on migrating uh, their product line from RPG 3 to modern Java. And I did the initial due diligence for that project, and also looked at, analyzed the existing work that had been done on the Java side to see how much of that could be used. Very little of it actually, because it was that old. And we wanted to find companies that could provide us with. It didn't have to be AI-based services, but they seemed to be the most attractive alternatives because they would do most of the initial legwork. So a lot of the analysis and a lot of the initial proof of concepts could be done using AI tools, and then part of my job would have been, or I was hoping my job would have been, to actually bring that modernizing the Java code up to modern Java standards, what I would consider to be modern Java standards. So
Okay.
that's me in a nutshell, basically.
Well, a lot of different experiences. So great. So
Yeah. But one thing I'd like to say to Federico is that software development isn't just about producing new things. It's quite a lot of the effort is based on taking code that's even just 6 months old and migrating that to modern, because things change. The algorithms we use, most of them are well known, well understood. With the introduction of AI tools, the heuristics which are involved, which hardly anybody understands, because you can't debug them. It's all data driven. The algorithms used to produce this are well understood and have been for a long, long time. All of the AI techniques that I learned at university are still relevant today. Huffman networks, neural networks, and so on and so forth. Even as far as RAG, the these augmented generative component in AI. We knew back then that it was possible because it was mathematically proven to be possible. We just didn't have the hardware. But now, with the preponderance of GPU systems available and hardware acceleration in SIMD in large architectures, we're talking about many thousands, if not millions, of GPU units being used for the inference engines. And that's the key phrase that I use. AI is not intelligent. What we have at the moment are just literally advanced inference or advanced search engines.
Yeah, it's.
And
I
they're
think.
very good at doing analysis on old code. So even if it's just 6 months old, you might have been the person who wrote it originally and look back and think, oh, did I write that? Oh, I'm not sure exactly what I was trying to do there, but, and now you've got a tool which you can say, what was I thinking?
Yeah, and okay, you mentioned the age of software, say even something that is 6 months old could need some attention.
Yeah.
And maybe I will expand on this and ask you a question that I always like uh, to ask in this podcast is, and that is, what is your definition of legacy code?
Legacy code is anything that has reached production, and the second it reaches production, it becomes legacy code and starts building technical debt. And this technical debt might be driven by the fact that your feature needs change, that you have architectural needs which have to be fulfilled. Say, for instance, you're transferring from just doing basically Docker or just running on bare metal, application servers running on bare metal, and then you want to move to Spring Boot, running in Docker containers, and then you go even further and you start looking at cloud services like AWS or OpenShift, and you start getting into the realm of Kubernetes. Now, a lot of companies look at things like Kubernetes and cloud services and go, oh, we have to have that because it means we don't have to invest in hardware. What they forget is that these are highly complex, or can be highly complex systems, and they do introduce several layers of abstraction and complexity, which your code is not going to survive that. You know, and just aging means that there's legacy. For instance, code that's a year old and it's written in Java, you will have at least a new Java version available if it's not LTS. Now, most companies want to go to the LTS version because of the security aspects that it's still supported. And you're going to have to, you want to look at, can I just literally build things using the new Java version, or do I have to change stuff? Because some code is going to be no longer available. This is true even for Java, which tries to maintain its backwards compatibility as much as possible. But there are things which are changing. For instance, the security manager is being deprecated and will be removed very soon. There are things in the Sun, or what used to be Sun is now the Oracle proprietary VM code, which you shouldn't use, but companies do, because we are generously allowed to do that by using certain runtime, certain switches for the JVM when we start all this kind of thing. But basically, you have to continuously plan and look at all of the code that you have and the systems as they're running. And if you think, okay, my performance is good enough, the code is good enough, it's well maintained. If we have bugs, we deal with them immediately. And then the thing that comes in, which you cannot avoid, is am I running on legacy hardware, old hardware? Am I running on old operating systems with completely outdated local infrastructure? Do I need to change my database? Things like this. And these are all factors which drive the change. And anything that says you have to change something, all that you're doing then is maintaining and migrating legacy code.
Okay, so there is a very wide spectrum of activities that fall under the scope of modernizing your code.
Mm-hmm.
And of course, in 2026, I have to mention AI. Well, you have already mentioned AI, and remember us that AI used to exist before LLM became popular. Very, very true and very important to mention. But with the evolution of AI and the introduction of LLMs, what role do you think that AI can play realistically in migrations and modernizing projects today?
I think that realistically, AI tools in their current state and the large language models in their current state are, or should be, restricted to analysis of the existing code base and how you can translate that, finding patterns which AI is very good at. What you call idioms, which I think is a very appropriate term, and being able to map that to modern language infrastructure. I'm not necessarily saying, okay, fine, do everything in Java. It may well be that C# or another modern language or language and infrastructure is more appropriate. Kotlin is becoming more and more, is being found in more use, not for Java backend, but for mobile application development. And there are certain things which Kotlin can do easily, which aren't as easy to do in Java for the backend as well. And it would be appropriate to try and get your AI to map the legacy systems onto a language system, a language platform like Kotlin is, or C# or whichever one you choose, which is your target. Other than that, I think you still have to be very careful. You have to be able to not only map the existing processes onto a new platform, but you also have to be able to check that what the AI is producing does actually match and match what's coming out. So for a given set of inputs, you expect a given set of outputs, and you have to be able to reproduce that 100% onto the new system. And this is especially relevant when you're looking at old code bases, which come mostly out of the financial sector or human resources with payroll systems and so on everywhere. And this is a lot to do with money. So I get paid a certain amount of money a month, and I expect my paycheck to be correct. And if I'm an actual employee of a company, then all of the other calculations, like how much social insurance do I have to pay, health insurance, how much retirement fund, and so on and so forth, my income tax. The income tax is probably the most important one, because if they get that wrong, you're the one sat on it, because the government will come to you and say, I need you to pay me the last 10 years this tax which wasn't paid. And your employer is not liable for that. Not in most countries anyway. Certainly
Oh,
not in Germany. Um, yeah, so you have to be very careful, and there's a certain aspect. How much do you trust your AI? Now, it may well be that you find, with the right guidelines in place and the right guardrails, the two different things that you need. Guidelines are general instructions which say what you want from the AI. Guardrails are things that you tell the AI never to do, like never write code, never rewrite something without asking, or change anything which can't be reversed, which is incredibly important. Um, and once you've got into that and you find that what's coming out of the AI is good enough, you're going to have to be able to massage this a little bit, and maybe refactor some of the code, but your major effort isn't in that. It isn't being put towards that, but making sure the AI tool does something. Now, what happens? Every 2 months, it seems, the pace is increasing. There's a new LLM available. There's a new AI system available, and things change. I was told enthusiastically, try this AI, try this. And I thought, okay, fine, I will. And it was terrible. It was very, very good at doing the analysis, but it just ran roughshod over my code. Now I'm talking about one single class. It something I'm working on, which I use as a basis for talks and demonstrations about augmented development. And basically, what it is I have a class called fast decimal, which takes the role of big decimal, but it accepts
mhm.
the restrictions of packing everything into a single long value, so that you can't have a large number of decimal places, and you've got a restricted range on the values you can use. However, it's very fast. Can be up to 10 times faster than big decimal equivalent calculations. The
Oh,
beauty of using this is that I can transfer this and say, now I want to run my things on SIMDs. So either a GPU, if you've got a lot of data you need processing, and you can leverage the SIMD component, or on vector CPU vectors. And so I use this one. I said, okay, fine. Now write some tests for me, and if you find any bugs in the highlighted by the test, don't change the test, because they use big decimals as the comparison. So those work. I have to assume that these are correct because they're in use in financial institutions, and if there are any problems with big decimal, then they would become globally visible immediately. And then correct your code. So what did the first thing the AI did was threw everything away. So you're running basically a line of, or you got a loop, and you take your long values and you just run them through the SIMD architecture with the basic operations. What it did was it just delegated everything to the original class, which had nothing to do with SIMD at all, and wasn't actually capable of running anything on SIMD architecture. So
yeah.
that, going from old, which was working beautifully for me, and I do a lot of comparison. How does this AI compare to another one? And I find some of them are really chatty. Some of them are, and they have this like anthropomorphic, this human way of communicating, which can be very subservient. I find it very creepy, actually, because I'm used to somebody telling me I'm wrong, and the AI is going, "Oh no, that's right. Yeah, that was a problem, and I'll fix it, and I'm really sorry." Um, and yeah, it can be. I try to. One of the things I put in my guidelines is I don't want to hear you say sorry. Just fix it, and so it reduces the chattiness. But some AI models I can't use. Um, it's simply because of that. It's the human interface. It's not the work that they do. It's the human interface, and the fact that they go through 7 or 8 cycles of getting it wrong before they either say, and this is true, it's happened to me, I don't know, and they finally say, I can't solve this problem, or they do eventually solve it, and it's like you're sitting there for an hour, and that's the one thing that a lot of people don't realize is they don't come up with answers instantaneously. They have to do a hell of a lot of processing, and it takes time. So this is time I would be using for writing code, or just watching an AI doing its thing. So careful. You have to be very careful with AI. Um, Parts of the analysis are going to be wrong. There are certain things which AIs are never going to be good at. Concurrency is one of them. Parallel processing is another. Simply because there is no concept of um, uh, concurrency in an AI, and it doesn't understand things like, it has no knowledge or very little understanding of things like race conditions and locking and making things synchronous and thread safe and so on. Because the vast majority of code which deals with this is terrible code, and it's all been written by people. And there's another aspect of this which I shall come back to at some point, which has to do with the fact that AIs are now being fed code written by AIs, which is really amusing. However, so you have to be aware of this, and there's a lot of people saying, "Oh, we won't need junior developers anytime soon because AI developer tools will replace them," which is absolute rubbish. Because you're still going to need senior developers, and where do you get senior developers from if the juniors aren't there? You can't bring them forward. So yeah, AI tools do have a very relevant place in the workplace in software development, not just software development, but also designing specifications for new features and so on. But like any tool, treat them as if they are tools and expect them to not work properly. That's the difference. If I have a hammer in my hand, I know that if I hit the hammer properly, if I hit the hammer on the nail properly, the hammer's going to do its job. If I'm stupid and I put my thumb too close to it, it's going to be painful. So the same thing. Treat AI tools with the respect they deserve, which is none. And it sounds horrible to say that, but they're not humans. They don't need to be treated kindly, or they don't need to be treated with respect. They just need to be pointed in the right direction. You need to control very carefully what they do, because what they're doing is not simply driving a hammer into wood. They're producing sometimes very complex and unreadable code, and and an AI won't try to be clever because they're not trying to do anything, and they're just repeating what they've got in their corpus of knowledge. And sometimes you can get real rubbish out at the end, but it looks plausible and may even pass all the tests.
Yeah.
That's one of the things I learned very quickly with augmented development, was the fact that you have to be really, really, really careful when you say to the AI, generate tests for the code that you generated. I give you the case in point. First thing, this is the first time I tried this with my fast decimal classes, and it generated the code, and then okay, fine, and then I said generate tests, and what it did was it generated the tests using the results from the code it had generated. So those are self-fulfilling prophecies, and then I thought, hang on, some of these results just don't look right, because I was being careful, and I was doing this as a proper analysis project. What's it like using augmented development, building up the experience for presentations and talks on the subject. And so I said, okay, fine. My mistake. I didn't tell you to use the results of big decimal operations, testing against the results of the equivalent fast decimal operations. And all of a sudden, it was finding horrible flaws in its code, but it didn't change the test, because that's one thing I do say is don't change the test if something's wrong. Look at the code and then analyze it. And if there's a problem with the test, then tell me or make the changes. And all of a sudden, it started working. And then I went to the next generation of AI model, and no, it broke again. But I have also noticed there's in certain constellations, in certain aspects, if you're careful with your prompting and you keep the scope of the changes you want small, which is great because fast decimal is tiny. It's literally 2 classes. There are far more tests than there are classes. There's one for GP. There's one for the vector API in Java, and there's one for the fast decimal itself. I'm also preparing things for the the project Valhalla in Java, which is not being released in Java 26, unfortunately. However, there'll be three classes, and then there's a whole bunch of classes for performance tests, which I happily let um, um, AI write with JMH, which is brilliant. It got it done first time. And a bunch of the code is very simple. Um, but anyway, yeah, I find incremental improvements that a later generation of AI model, the LLM, has had new code added to its corpus of knowledge, and the LLMs are better at inferencing, and it will make slight perform or slight optimizations in the code that it generates. I look at it and I go, now this is on the level of bit twiddling, which I don't really understand. I'm not a mathematician. However, the results still work because the tests aren't breaking. So, yeah, I am optimistic that AI tools will do work, and they definitely do have a place. However, I'm still not convinced that they're trustworthy. That you can just say do it and then go home or sit back and relax and watch. Horribly
Good.
dangerous.
Yeah. Well, a lot to unpack here, but I want to just share an anecdote about something you mentioned a few minutes ago about AI and concurrency. And it's just an anecdote, but I was working on a parallel algorithm and I had an issue, I couldn't fix it. I asked an LLM to help me. It solves the problem by just using one thread instead of many. Say, okay, thank you. I could have solved it myself. But yeah, no, but just an anecdote. Uh,
I've had the same experience, by the way. So I
and,
can reinforce that anecdote. It is true.
yeah. And maybe mm, I wanted to ask if there are some factors that you have seen differentiate the projects, the legacy modernization project that goes well from the one that goes poorly. Do you think is there any factors that makes really a difference?
Um, Definitely. The original source base, what language and which infrastructure is being used. For instance, we mentioned IBM and their COBOL AI transformation tools. Um, IBM also have RPG. RPG is a completely different beast, and I'm not convinced that it's going to be effectively practical possible to have a clean Java generation out of RPG for various reasons. One of which is the fact that IBM themselves haven't been able to make an LLM which properly understands RPG. One of the reasons for that is RPG is an extensible language and runs on a yeah proprietary infrastructure which has constructs in it which are thoroughly alien to even the COBOL world, which uses many of the same things like files and so on. Other factors are how good is the original code base. You can have really, really well written RPG, which doesn't use any or many of the uh, proprietary also language extensions, and so on. And there's enough there, so you got good clean code at the beginning, and you can get good clean code out the other side. Now you may have RPG artifacts being reproduced in Java, but you can get around. You can work those out. The same with COBOL, even easier. You could take legacy Java code running, say, written for Java 2 or Java 4, Java 1.2 or 1. Or 4, which I've had recently, and you will. It is actually much easier to use an AI tool to clean that up because you can say this is Java 1.2 and I want Java 8 out of it, and then from Java 8 you progress to Java 17. These are all the milestones. Java 17, and then from Java 17 to Java 21, and then if you're feeling brave, you can go from 21 to 25. Although the jump from 17 to 25 is nowhere near as bad as Java 1.2 to Java 8, simply because there was so much evolution uh,
Yes.
from Java 1.2 up to Java 8, and certainly the jump to Java 8 introduces things like lambdas and functional programming and so on. But even basic things like the Java 1.2, you didn't have the collection API, so you're stuck with using vector, which is thread
Yes.
safe, doesn't need to be,
True.
or hash map, hash table, sorry, and stack. Those were the three you had. Everything else you had to write yourself. But yeah, AI can do that, but it depends on the quality, and this is the biggest factor, I think, is the quality of the code you have at the beginning will determine the quality of what you get out of the other side. Also, does the language, the original language and the original infrastructure itself, is it also conducive to such migrations? And unfortunately, there are some languages like RPG which aren't. And this isn't just the older RPG; it's with the new RPG as well, where they're introducing the concepts of SQL for everything. And I think that's a very misguided idea, because SQL is great for managers who want to get information out of data, but not for SQL for everything. It's driving your code, and it stops being a language in the same sense that RPG is. So some of the directions that companies are going in. Also, if you've decided, especially in your RPG world, that you need to add extra complexity with language extensions, and a lot of companies do this, you'll find that these do not translate at all. Never mind well, but they just don't translate over to modern software, regardless of what your target platform is. You literally have to rethink this and say, okay, fine, we needed this feature back then, but we don't need it now. How do we replace it with an alternative, or do we just say don't? We don't need this at all. We don't want it in. So you have to do a deep analysis of what can I expect out of a migration, and what should I leave behind. And AI is not going to do that for you. However, it can identify things that might have problems with. So it's still very much a tool. So, and also, do you have anybody? Is there anybody around? This is an interesting factor, I think. Do you have anybody around who actually was involved in creating that software originally, or are you looking at something which is almost certainly going to be poorly documented, poorly maintained, and there's nobody around, so you have absolutely zero knowledge base to try and unscramble what can be really difficult code to decipher as a person, simply because it's very cryptic. RPG, COBOL, they're very cryptic because of the restrictions on things like function names and variable names.
The part about code quality really resonated to me, because typically we deliver at runtime that we build from scratch, and then we deliver the migrated code, and sometimes the client want to have some quality checks on the runtime, no problem, and on the migrated code, but the quality of the migrated code is very much influenced on the quality of the original code, because if the original code was a mess of go-tos and 10 loops in a function that was 10,000 lines long, well, the complexity of the new code will not be great.
No.
And, yeah.
But it's not your fault. You're given code which is terrible, and this is a very old rule: garbage in, garbage out. That is a rule that will never become old, will never become irrelevant, because it is how, like as you said, the quality of the code at the beginning influences and determines very much the quality of the code at the back end. Unless you can find some magic which says, I recognize this kind of anti-pattern or terribly written code, and I can massage the kinks out straight away. If you can do that, you're a genius, and probably only have to do one project and then retire for life.
That sounds a good plan.
So why haven't you retired yet, Federico? Come on, you're a genius.
Maybe I'm not such a genius, you see.
Yeah.
Yeah, but thank you, Andy. This was my last question.
Great.
I think there are a lot of nuggets for our listeners to reflect on, and I think this conversation has been very valuable because, as I said at the beginning, we live in uncertain times. Everybody is asking what is going to happen in 3 months or 6 months or 1 year, and having someone that look at this with the experience of having seen decades of evolution and now with knowledge about the possibility of AI, I think has been very interesting. So thank you a lot, Andy.
Yeah, my pleasure, Federico. And if you need me, then please don't hesitate to call. Or if you need
Great.
me again, that is.
Thank you. I will.